Okay, it is Tuesday of week number 2. A little bit about what is limits. And today we're talking about the precise definition of a limit. And we discussed a little bit in regards to what they gave us and the fact that we did a whole bunch about removable points and non-removable points, when it exists, when it doesn't exist. Well, in this one, it's proof of the existence of a parameter. A parameter is that in the real world, we call it margin of error. That something will exist, right? Something will happen, will exist. So we introduce several things here. And we're going to start off the lesson with a number line. And this is for graphing of of an inequality, because it gives us the parameter of some possible solutions, right? Things that fit into that group. Do you understand why we're reviewing this? Okay. Because as we look at mathematics, there's nothing you haven't already done. And I guarantee that. It's just a matter of how we state it in a theorem or an axiom. Okay, and it can be baffling. Well, we're not going to be baffled. We're going to take it easy. So we have a compound inequality here. Does it have a closed or an open condition for the interval? Open. It's not closed. It has less than. So therefore, we have either parentheses or the open dot. And I'm going to use parentheses because that's what we'll be using in our consideration.
And the line underneath that.
Yes, it will include that number that's first stated. Of course, we understand that there's infinite number of possibilities between any two digits, infinite many. And that goes into that precision aspect. And that's a great point. Thank you. Yes, we have this guy, which includes the value. And then we have this guy, which is close, so close it could be it. Thank you for that. I appreciate it. Right. So now that we've clarified that, we're going to talk about the fact that the variable always has to be in the center of a complex inequality so that we can do it. And that would be our first charge. But this is just for instructional purpose. And none of what you do is difficult. Guaranteed. Nothing you're going to have on this homework is difficult. So we're going to say, okay, if I'm solving for x, I am going to add 4 all the way across. When I do that, I'm going to have a -5 is less than x is less than 11. So now I have the parameter. If I was to do the interval from this guy, I would have -5, comma, 11 with parentheses because we would not include the first digit and the last digit in the answer possibility. Is everybody comfortable with that? Okay, if we were graphing it, I would say I'd have a -6, a -4, a -2, a 0, a 2, a 4, a 6, an 8, a 10, and a 12. All right. So I'm figuring out, because I know what I want to graph. Well, we want a -5, and we would want the +11. And if we graphed it, this is the area that any one of these digits included in the parentheses would make the statement what? Huh?
True.
True. Okay. It would make the statement true. I want that to solidify in your brain because it's not It's a más o menos. We can pick any one of those digits in between there, and the statement would be true. So we have another one that we want to do. And this one is just interval notation. And in this case, we have only two arguments. In this case, we have something different in our example. What is it? The bar. It is a closed interval for one section, of course. All right. So our first step is to move all the x's this time to the left. So I'm going to remove the 4 x's. That'll give me x on the left plus the 4 is greater than or equal to 5. Now I'm going to remove the 4 from both sides. And that gives me x is greater than or equal to 1. Always check my math. I'm not going fast, so I'm pretty good right now. And that would mean a bracket, a 1 comma to infinity. This guy, the infinity, always has a parenthesis. We don't know what it is at the end, but we know it does exist. And there's always one number you can mention that is bigger than that. At one point, the Google was the biggest number. And of course, now it is not the biggest number known or accounted for. So that's why Google took that name, because it was the biggest number of data that you could have in your format. So, but,
Right.
right. And it's used. It is used. So, okay. So now we're getting to the heart of this particular lesson. And that is the precise definition of a limit. And I'm going to read it to you as well as you read it yourself. Let f of x. Now remember, what does the f stand for? Function, which means for every x there is a defined y output, right?
Yep.
A function has to have that. And it can be restricted in domain, but it has to have that condition. All right. Be defined on an open interval about C. Now, some math books use different lowercase letters. Lowercase letters are numbers, and those numbers exist in the performance of whatever they want us to do. But this textbook uses C, except possibly at C itself. And we know that's a fact because we could have a what? An open hole, or we could have a piecewise that says the value is something outside of the two curves around it. So all of those conditions, it can be at C or possibly not be at C. We say that the limit of f of x as x approaches C is a number L, capital L. Capital L defines the existence of that value as concrete. Now, is it concrete? No, but it's close enough, right? I mean, remember, we said infinitesimal till we get to that open dot. All right, and we write it as the limit as x approaches C of f of x is L. This is what you carry on your notes. That's the one. Okay, if for every number epsilon greater than 0, now epsilon is that Greek letter that we're using for our distinction of output. Epsilon, there exists a corresponding delta greater than 0 such that the absolute value, and this is our equations, if you will. These are our equations, and we need to write those down for the time being to make sure they solidify as we go into our worksheet on Thursday. The absolute value of f of x minus L, being the limit given, is less than epsilon, whenever 0 is less than x minus, what was C? That's the number we put the limit to. The x value limit to is less than delta. It doesn't reach delta unless it has the bar under the inequality. Sometimes we can reach that delta, but normally it is just less than. Okay, is everybody good? All right, so let's take our first example. Is everybody breathing? Am I going too fast? Okay. Consider only the fact that this is a precision of the limit, and it gives us parameters of existence, an inequality grouping of values around what value? C of C. All right, the one we're looking a limit for. So here's our first example, and it's cheesy. And the reason it's cheesy is because we want to start easy and evaluate some of the information I have not given you. And this is one of those problems. We're going to sketch the interval AB. Okay, that's the limit of the domain AB, or this C exists. Can it be outside of AB? Can she be outside of AB? Well, no. It's a parameter. It lives somewhere in there. We have to figure out what it is and other things with this. All right. On the x-axis, which means it's the domain area of this limit, with the point C inside. Okay. Then find the largest value. Okay, now this is misleading. The largest value is the value that is shared by both sides of that condition. That's the largest. Not the value that's the largest, but the one that is shared by both sides. That would make it the largest parameter we should use. Is everybody comfortable?
Mhm.
All right. Okay. Okay. Where delta is greater than 0, such that for all x, 0 is less than the absolute value of x minus c less than delta, implies a is less than x is less than b. Okay, so here we have, all right, so they want us to do a number line. We're going to do a little number line. I'm not the best, but I work hard at it. And we have our AB. Now remember, the smaller a negative, the closer to 0 it is. So it doesn't look like it's supposed to be. I mean, a third, if you take it on its own, is bigger. But no, it's further away from 0 than the negative 1/8. Is everybody comfortable with that? The negative 1/3 is smaller. Good, good. All righty then. So I'm going to write a 0 here and a negative 1 here. All right. So I'm going to go a negative third. 1, 2, right about here. And a 1/8. A negative 1/8, sorry. Okay. And it says there must be a C that's a negative fourth. And yes, C lives between that interval. Is everybody comfortable with that? All right. Now it says find the largest delta we can have. All right. That means shared by both. So that means we're using the absolute value of x minus c is less than delta. Well, we don't know what delta is. We're trying to figure out what delta is going to be. So that means we know what c is, and our x's are, for A, it's a negative third, and for B, it's a negative 1/8. Does everybody see that? Alrighty then. So now we're going to do our A equals negative 1/3. All right. All right, so I'm going to have two negatives. Make a positive. I need a what to solve it? Mathematicians, what do I need? Thank you. And it's an easy one. They're all easy. They're going to be 12. And if you are unsure, you can always stick it on your calculator and then hit math and frac, and it'll give it to you. All right. So this is going to be a negative 1/12. And of course, therefore, this delta is 1/12. Now that took care of that one. Now we need the b. So if b is a negative 1/8, I'm going to have the negative 1/8 minus our c, which is a negative 1/4, has to be less than some delta that we described. Two negatives make a positive. Now this one is 8, isn't it? So I'm going to have a negative 1/8 plus, and that's 2 8s, right? So I'm going to have 1/8. How's everybody doing? All right, now, which is smaller? 1/12, because there are more pieces in the 1/12 than there is in the, yes, all right. So what is the largest value? 1/12 for delta. Everybody breathing? Is this horrible math? Is it like sci-fi? Okay.
Pain in the butt drawing delta.
Me too. We're going to have this guy right here, and we have a picture on this one. I love pictures because they give us something to draw from, especially as to the parameters that are implied, correct? Implied. All right. So we're going to read, because I have a tendency to glaze over everything and think I know what to do. Use the given graph to find the largest value of delta greater than 0. We just did that on a previous one, such that for all x, f of x minus the limit given is less than epsilon whenever 0 is less than the absolute value of x minus c is less than delta. And that is the precise definition of limit. So we have our function. We have our c, we have our limit, and we have epsilon. All right, and they want the largest value of delta. Okay, well, we don't have to do anything but subtract the deltas. What are my deltas? Oh, yes. So the interval for delta is 4 8/10 to 5 2/10. Now, we could have done it going with epsilon and then getting that same interval, but that's a lot of extra math. This is drawn to scale. It is a line. A line is precise. Is everybody comfortable with that? All right. So what we need to do then is to do what we did before. We're going to figure out the absolute value of x minus the c has to be less than that delta. All right. Is everybody comfortable with that? Okay. And our c is what value? 5. Is everybody good?
Mhm.
Alrighty then. So I'm going to have the 4 8/10 minus the 5 has to be less than delta.
Mhm.
That's going to be the absolute value of negative 2/10, isn't it?
Yeah.
Which makes it 2/10.
Right.
All right, that's one of them. So now let's see what the other one is. So on the other one, I have 5 2/10 for x, and I'm taking away my c. And in this case, they're what? Identical. So it is the same. So the largest delta is 2/10. In the real world, we're talking 1/10, 1/100, depending on the precision of what you want, and 1,000. But in this course, you'll have as much as 5%, 50%, 0.5. But that's just because of the nature of the math. Is everybody comfortable with that? In the real world where you're going to be living. All right, we have another graph. And this one says we're using the graph and we want to find the largest value of delta. So this one is just a little higher math because, and I'm going to put it lower, look at the fractions. Yeah. All right. Now, in this course, they ask you to simplify to certain degrees, certain decimal values, or exact answers. In this case, it's an exact answer. Is everybody comfortable with that? Trust me, in the long run, it's going to be okay. Now, on my notes, I worked it with the epsilon, and then I worked it with, but trust me, these are correct. Okay. So we're talking delta, and our delta lies somewhere. Our largest delta lies somewhere in between this guy. All right. Is everybody comfortable with that? Here we go. So we're going to structure it. Now we have our interval, and we have our C. Is everybody comfortable with that?
Does C always lie in between the intervals?
Has to.
Has to.
Has to.
No.
Otherwise, it's a no-go.
Yep.
And we have to be careful. And we're going to have a problem with signs as well. Right. Because you can have a negative value, an interval with negative values. It doesn't affect the delta. Delta is always the absolute value.
Right.
So, but you have to be cognizant of where you're living in order to know the distinction. Is everybody comfortable with that? We'll do one in a minute. Everybody breathing? Alrighty then. So we're going to do this guy right here. This guy. All right. And so we're going to insert these ugly things in there. And I have 9 as C. Mm-hmm. All right. So I want 9 to be parts of 81. So how do I get 81? I multiply by 81 by 9. Yes. Yes. So I'm going to multiply this guy by 81 over 81 so I can have a common denominator. Is everybody comfortable with that? And that's why I'm saying that it's going to work out real nice. Let me see. There it comes. Everybody verify. Oh, I was working. I always work. Sorry about that. So I'm going to have 81 times 9. And I'm going to get 729.
Mhm.
All right. So now I'm going to do the math. Okay. And, oops, sorry. Sorry about that. Well, didn't want to split my screen. I'm sorry. So I'm going to enter only my numerators because the denominator does not change. Is that okay with everyone?
Correct.
All right. 676 minus a 729. All right. So delta is less than that number for the first group. Now we're going to do the second one. All right. So which is the largest delta I can have?
Over 81.
Which one?
Second one, 55 over 81.
Wait, which is the smaller?
Oh, wait,
You have-
3 over 81.
Yes,
Yeah.
yes. 53 exists
Yes.
in the 55. Therefore, 53 is the largest delta we
That's right.
consider.
That's right.
It has to be equidistance. Everybody good? Very nice, class. Thank you. Thinking, thinking, thinking. I love it. All right. Now, here we have an epsilon given to us, a C of 3, an L of 18, and an f of x as a line. And they want for the given function f of x and the values of L, C, and epsilon greater than 0, find the largest open interval about C. Now we want the parameters, the whole thing, the whole shebang. Which the inequality f of x minus L is less than epsilon holds. Then determine the largest value of delta greater than 0, such that for all x satisfying the 0 less than x minus c absolute value is less than delta, the inequality f of x of L is less than epsilon holds. So we're doing two things. Okay, so we work with what we have. We're given this, this, and this. Therefore, we're doing the epsilon to find the value of x. Is everybody comfortable with that? All righty. So on that guess, I'm going to have f of x minus L has to be less than epsilon. Okay, I'm going to put what I know. Right. In order to remove the absolute values, we have to do the negative on the left.
Correct.
And I'm going to add those two, and I'm going to get 12, I think. All righty. Does everybody agree with my math? All right. To undo a complex one, which is how I started this whole thing, I'm going to add 12 to all sides. This is going to give me 1188. 12 and 12. All right. Now, I don't know that one. I'll make a mistake. So I'm going to get my calculator out. And I'm going to 1188 divided by 4. Everybody check my math now. 297.
Yep.
Good. And this one I can do. Okay, so my given interval surrounding L with an epsilon given is this. Okay, so my interval, because it's X, does 3 live inside AB?
Yes.
Yes. So we're good. Now they want the largest. So we have to do that little math again. Do my A first. And when I do that one, it's 0.03, I think. Check my math.
Okay.
Okay, got the first one. Now I'm going to do the second one. Usually what's supposed to happen, doesn't always happen, but it's supposed to be, that's the largest. Doesn't matter which one, it just asks you what is the largest delta we can have, and it is 300ths. How we doing? Questions on the math, questions on the process? Anything? All right, well, we got another one. What's different with this one?
Got squared.
I know. Oh, and what else is different?
It's a negative C.
Yes, so our parameters are negatives.
Correct. Right,
Okay,
that's-
even though we're going to get positive out of it,
Right.
we have to make it
Negative.
negative in order for C to live in it.
Right.
And it's a parabola, so it is a mirror.
Mhm.
Boom. So we can assume we can stick numbers anywhere we like.
Correct.
Everybody understand why algebra was so important? If you can't visualize, you can't do this stuff with certainty. Okay. All right. So we have all kinds of things. I have to read it now. For the given function f of x and the numbers LC and epsilon greater than 0, find the largest open interval about C on which the inequality f of x minus the limit is less than absolute value is less than epsilon holds. Then give the largest value of delta. All right. Okay, here we go. We are given all of it in terms of epsilon. Does everybody see that?
Yeah.
Anybody not? Okay, because we didn't have anything to work with delta. So we're going to go epsilon to get the interval. Go backwards, if you will. So we're going to use this guy right here. Does everybody get? Okay, I'm going to put in what I have. And my L was 25. Okay, now I'm going to remove the absolute value symbol. Now I'm going to add 25 to both sides. Now what am I going to do? Say it louder.
Square root.
Absolutely. We have an issue. This is the positive. I need the negative, right?
Mhm.
So if I multiply by a -1 all the way through to get that negative capability, and it changes the direction of the inequality. Because we know that the smaller is going to be the larger value. All right, this is my interval. Correct?
Mhm.
Very good, class. Way ahead of the curve, way ahead. All right, now we got to figure out which is the largest delta. That's the one shared by both outcomes, the one shared by both outcomes. Oh, I'm so excited. All right, so I'm going to have my x minus c has to be less than the largest delta. So I'm going to have a negative square root of 24 and 9/10 minus the -5 is less than delta. All right, and we're going to do it by calculator, of course. And we're going to clear that mess. Oops, sorry. Clear it. And we're going to enter. And I'm going to do it without the symbol. We know this is a positive. Say 9. Okay. You got to show a whole bunch of decimals on this guy.
Look at +5. Yeah, got +5.
Thank you. I was going to say that's awfully large for a delta. I forgot the +5. Thank you. There it is. All right. Now we're going to do the other one. Got a 0. Sorry about that. I could enter. All right. So which is smaller? This has 2 zeros. Very tiny, right? This one's a little bit larger. It's further away. I know it's very confusing. So we're saying that this guy,
You said visualize on a number line. It's backwards.
Yes.
It's larger, it's actually smaller.
yes,
It's backwards.
it's backwards and it just drives me nuts.
So you just visualize it on a line. Which one's closer to zero?
Is it closer? Is it?
Is that right?
That's right. Maybe it is the other one, right? 0.1. You might be right.
Oh,
Because this one, no,
no, it's,
no, I'm right.
yeah, this point.
Yeah. Now I'm second
This is
guessing
back.
myself.
Remember, because it's back. Going the opposite.
And the answer would be the exact answer because of the decimal placement. It both come out to be 0.01. So you have to put the exact answer on that question. All right. We're going to take a break because that's all I have on this section. And then we'll get to the next.